Okay, so let's look at some practice here. Write the ground state, orbital diagram, and electron configuration of magnesium. Pause the lecture and see if you can get it. So the first thing we want to do is find magnesium on the periodic table, and it has atomic number 12, so it has 12 electrons. Now remember, the orbital diagram, we're placing boxes or lines or circles that represent each energy level and the subshells within them. So we have 12 electrons, and we're going to start off with our S, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And in the P, I put everything unpaired, and then I realized I had more than enough to fill it, so then I paired them. This is what your orbital diagram should look like. And now that we have our orbital diagram, the electron configuration is easy. 1s2, 2s2, 2p6, 3s2. And we can also use our noble gas condensed electron configuration. Here's magnesium, here's neon, so neon will take up the first 10 electrons, and then we're in our third energy level, so 3s2. So if you've got this right, give yourself a big pat on the back. Okay, now let's take this one step further. Write the ground state orbital diagram and electron configuration for the fluoride ion. Now this is the first time we're looking at an ion, and when we're doing electron configurations, what we care about is the number of electrons. And if we have a charge, that means our number of electrons and protons are not the same. So here's fluorine on the periodic table. It has atomic number 9, so as an atom, it has 9 electrons. But our example has F-. That means we have an extra electron, because electrons are negatively charged. So we have 10 electrons. So now that you know that we have 10 electrons, go ahead and see if you can figure out the orbital diagram and the electron configuration. Start the lecture again once you have an answer. So here's our orbital diagram, and I've just written lines here for simplicity instead of the boxes. 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And for the electron configuration, 1s2, 2s2, 2p6. And if we were to look at the noble gas configuration, this is what it would be. Neon has 10 electrons. Now, this is not to say that F- is the same as neon. It is not. F- still has 9 protons, and it is the protons that defines what element we're looking at. So even though it has 10 electrons, like neon, it does not turn into neon because it has a different number of protons. The reason it wants 10 electrons is because with 10 electrons, it has filled subshells, which is extremely stable. The electron configuration for neon is very, very stable, which is why F really wants to have an extra electron. So that's why we put our configuration in brackets. It's just the electron configuration, not the identity of the element that's changing. So we looked at an anion, now let's look at a cation. Write the electron configuration for the scandium-3 cation. All right, so first we got to find this on the periodic table. Here's scandium. As an atom, it has 21 electrons because its atomic number is 21. However, we're looking at a +3 cation, which means we've lost 3 electrons. So what we have are 18 electrons. Remember, if we have a +3 charge, that means we've lost 3 electrons. Okay, so where are these electrons going to go? Well, you can either use your diagram or the periodic table. I'm going to use the periodic table since I have one right here. Okay, 18. I'm going to start off with one S2 and go to my second row, 2S2, 2P6. That takes care of 10. I have 8 more to go. 3S2 and 3P6. That takes care of my 8. So I've ended up down here with a noble gas configuration of argon. This is a very stable ion. Why? Because it has filled subshells. When scandium loses 3 electrons, it gets a very stable electron configuration, that of a noble gas. And let's go ahead and write the orbital diagram, just to make sure we haven't forgot how to do that. Okay, 2 electrons in the 1s, 2 electrons in the 2s, 6 electrons in the 2p, 2 electrons in the 3s, and then a filled 3p subshell. So this is what the orbital diagram looks like.